Hello, I'm going to give you an introduction to some of the laboratory techniques that we're going to be needing to use in this lab focused on the equilibrium constant. And so in this case, we're going to be focusing on measurement of volumes accurately in choosing glassware. And so we'll have some solutions that are made up for us. This is an iron nitrate solution. And I have a 4 times more concentrated solution in this bottle with the bottle top pump that we used in the previous lab. And we have some potassium thiocyanate solution. And we want to make up some mixtures of these, and we're going to measure the absorbance with the SpectraVis Plus. So I'm going to demonstrate the use of these graduated pipettes. So this is a different kind of pipette from the one we used in the previous lab. The previous lab was a volumetric pipette designed to deliver very accurately a particular volume. And here we can choose volumes along this whole graduation. And so we can decide how much to draw up in here, and we can let that be delivered to our sample. We could use the vacuum bulbs to pull liquid in, but we are going to have available the pie pump, which will allow us to draw in liquid to a particular point on here and then deliver it to where we need it. These are marked on the top blow out, so that makes them different from the volumetric pipette. The volumetric pipette is designed to be very precise about the volume. So you go to the meniscus at the mark on the neck, and then you let it drain, and it's designed so that a little bit of liquid will be trapped in the bottom to deliver that precise amount of volume. But this one is designed so that it will deliver that volume if you blow it out, and we can use the pipe pump to do that. So we have a different kind of pipette, and so once again, I don't want folks to draw liquid out of the stock solution bottle. What we're going to do is we're going to take 6 mLs of this potassium thiocyanate and deliver that to a clean dry beaker. And this graduated pipette has a 0 at the top, and then if you fill it to that 0 mark and then deliver everything, it'll be 10 mLs. So you have to do a little bit of mental math. If I only want to deliver 6 mLs, I'm going to have to draw liquid up to the 4 and deliver that. And I need to have a beaker that will allow me to pour out 6 mLs plus a little bit more, so that's the smallest beaker. So here's going to be, I think 15 will be plenty. So I'm going to pour into there. And now I'm going to use my pie pump to draw liquid into the mark that is a 4. And it's going to be delivered to this beaker. So I'm going to put my tip down in, and I'm going to draw liquid in. I'm going to try to be sure to keep my tip underneath so I don't get any air bubbles in there. And I'm going to bring it down to the 4. And it's tricky to keep your tip in there and have it right at the floor of the meniscus. And then I'm going to deliver that 6 mLs to my beaker. So it's a challenge here to be as accurate as you can be to get the best results. But there I now have delivered 6.0 mLs to this. And then I'm going to add 10 mLs of the more concentrated iron nitrate solution. So this again is like we demonstrated before. You go up to the top, you drive it back down, and you've delivered 10. So the final volume here is 16.0 mLs. We want to make sure that we've got it well mixed. And I'm just going to model for you a little gentle swirling. It could be down on your lab bench. And that probably is preferable to trying to find a, here's the swirling. Preferable to finding a stirring rod out of your drawer. So now this is the solution that we want to put in our cuvette. And this has a little bit of that deionized water used for setting up the SpectraVis Plus spectrometer. So I'm going to model for you also how you don't need to clean and dry this. This has water in it. I'm going to pour this in the sink in the center. I'm going to shake out any excess drops. So there's a few bit of drops in here. I'm going to pour some of my liquid in here. Now that will be a little bit diluted by that water that was in there, but I'm going to pour that in the sink. And then when I fill it up a second time, it is going to be with those extra drops removed. So that's how you can use a rinsing process to get your solution placed in the cuvette. And so you don't need to go wash and dry this thing. You can use rinsing to make it ready accurately for the next solution. I have the little triangle here, which I line up to this triangle, and I'm ready to make my measurement out of my spectrophotometer. Okay, the last thing I want to do, you're going to make up one of those solutions, and then you're going to make up 4 other ones that you're going to do a little calculation to figure out how much of these different 2 solutions you're going to use, plus some water to make up the total volume of 16. And then when you're done, I want to model for you how you can get your beakers cleaned up at the end. We can simply run that solution in the sink, and you can rinse it well with water, tap water from here, or the sink in the back of the lab, and then rinse it with deionized water. Take out that excess water. So it's not perfectly dry, but it'll dry just fine in the drawer, so that's going back in the drawer. These beakers were out here on the desktop, so I'll leave them out here because that's the way I found them. But if you find your beakers from the drawer, the wet ones can actually go in the drawer and they'll be fine. So that's a way to guide you through the lab with some simple techniques, and wish you well in the lab.